if you talk to industry analysts, which is apparently something I spend half of TC doing, if you talk to industry analysts, you'll hear that maybe 80% of data science projects are failing to deliver their business outcomes. How many people think that's a good estimate? Yeah? How many people think it might be high? Okay, how many people think it might be low? I'm in the low camp. But one thing you get if you chat with some of these, I got quite the echo voice of God thing going. One thing you get chatting is actually what I've found is like 50% of data science projects like don't even have business goals, business outcomes. How many people are aware of a data science project in their organization, anonymously, that has no discernible business outcome? Yeah, how many people are aware of like a $2 million budget project with no discernible business outcome? Yeah, like more than a few. You could pay for a lot of stuff with that money. But people start these projects, they fund these projects, they execute on data science because they think that data science is going to be a big deal, and they're pretty sure that if they like data science hard enough, then eventually they'll get some good result. One of the things I found, hi, I'm Richard Tibbets. I was the CEO at Empirical Systems, which was a spin out of MIT. It was an AI company that was acquired by Tableau about a year ago. And in the first 18 months that I was working with the research project and with Empirical, I had a version of our core algorithm that was fundamentally broken. It looked like it was giving you good answers. It gave you answers that were the right shape. I used to say they were truthy answers, but it was flawed in some of what it did. And what I found, that's when I developed this slide. What I found was that people will trust anything in a fixed width font. They really like telling themselves a just so story for why the numbers came out like that or why that thing is a driver of that other thing. And I'd be sitting there, like I wasn't shy. I'd be sitting there saying, no, the software is pretty buggy. Like this is early stuff. I'm mostly doing this product management exercise where I just want to know like if this software gave you right answers, is this the type of interface you'd want on it, et cetera. There was only one customer out of about probably like 50 pilots. There was one guy named Isaac. He was the number 2 at a quant hedge fund on Wall Street. And he was the only person to actually run the numbers against some other system and come back and say, hey, like I modeled your residuals and this is a mess. And at the time it was very convenient because I was able to say, oh, we have a new version of the model that we're about to ship. And that was good because yeah, we did eventually catch up to reality. But along the way I found that people are remarkably open to getting absolute nonsense out of computers and trusting it. Yeah. So welcome to a talk about making business more Bayesian, maybe making people more skeptical, helping people to make decisions based on data and analyses. I'm going to talk through a bunch of different things today. Artificial intelligence and decision support. We'll talk about the importance of domain expertise. By the time you leave, you'll realize that I think that's kind of a big deal. Conveniently, I'm at a Tableau conference. And also about being Bayesian and using technologies like explainable AI. I'm also, now that I've come to Tableau, we've had the good fortune of shipping and announcing this morning Explain Data, which is the first capability based on the Empirical engine. But I'm going to talk about explainable AI in general, not just what we're doing with Empirical. And there are other talks this week that are awesome. In fact, there's a talk like right next door, right after this, about how to lie with statistics. It's like a perfect pairing, if that's your jam. There's also, I'm giving a talk tomorrow on machine learning and explainable AI. That's going to be more technical, like how to plug these things together. My co-founder Madeline's giving a talk on how your data does not tell you that, which is sort of the inverse of some of what we're dealing with here. So let's get into it. People may have heard, I don't know if anybody's been to the show floor yet, but like AI is like kind of a big deal. In fact, like AI is changing the world. People can fight endlessly about what AI means, which is sort of what happens when something's changing the world, I guess. Vikash was my colleague at MIT. That's a cute statement. I'm a fan of the later one. Computers just doing stuff that surprises us. The computers can do it. But a weird thing about this is if you look at the media, you look at the data, you look at people, you talk to organizations at Tableau, organizations that are doing this stuff are having better outcomes. Organizations investing in data science are doing more. Now, there's an interesting question of correlation and causation there. And this is an appropriate thing to bring up in this room. Organizations that make giant piles of money also spend more money on coffee. They have better coffee. But nobody thinks that the coffee is what causes them to make piles of money. So we'll see. But we should hang on to that question of what's really going on and why do we see better outcomes when people are investing in AI. But first, we're going to wander around and talk about a lot of other stuff. I really like the phrase decision support. I think it used to make me seem old. I think at this point it's like a hipster thing. Because why are people looking at data? They're oftentimes wanting to make decisions. People have been trying to make decisions for a very long time. Anybody know what this is a picture of? Come on, speak louder. It's a big room. Venice. How many have people been to Venice? It's like really nice. Anybody know how Venice got to be so nice? Like what happened? Like how they got so rich? It's not because they're an island, though that's not irrelevant. It's actually something totally relevant to the conversation we're in right now. Venice invented double-entry bookkeeping. In fact, probably, depending on how ambitious the historians you favor are, probably Leonardo da Vinci's boyfriend was the first person to document double-entry bookkeeping. He was paid by his patron to do it. He was writing this big book that was trying to be a documentation of all the math in the world, and the only thing his patron said that he had to put in it was how to do double-entry bookkeeping. Because from his patron in Venice was like that was the math that mattered. Because with double-entry bookkeeping, you could all of a sudden make decisions and do stuff with assets that you didn't actually have in your warehouse. You could own something without touching it. You could buy something and sell it again without it like moving through. You could just keep track of what was going on in your business. And that turned out to be like kind of a big deal. And so like Venice got huge. And there have been lots of other improvements along the way. I won't go into why I included all of these things, but SQL databases have been kind of a thing. In my defense, I made this first version of this slide almost 2 years ago before I sold the company to Tableau, and I had Tableau in this slide. So I'll just have you know that Tableau is a pretty credible stage in this process. But there's this progression forward, regardless of what you decide to put on the slide. There's this sort of progression forward as we're coming up with different data management tools. We work with larger volumes of data. We make things more accessible. But a lot of people seem to have this idea, maybe they say it out loud, maybe they don't, that there's just like something's going to swoop in, and all of a sudden, all of this decision support is going to be completely disrupted by like Skynet. It's just going to make all the business decisions. And I see this again and again, and it's very strange to me. I was chewing out an analyst this morning because they have this tendency to draw these pictures that go up and to the right, and you move through your sort of explorer or your descriptive analysis, and then eventually you're doing predictions, and then you get to do prescriptive analysis. And this kind of picture really makes people think that you're supposed to get there, that that's like somehow the goal, that most of your analysis should eventually become prescriptive. I think that's totally wrong. There's an enormous amount of analysis, and we'll come back to this again and again. There's an enormous amount of analysis and decisions that people make that are non-repeatable, that are non-amenable to automation, that depend a great deal on knowledge, domain knowledge. So I don't think that we're actually going to get to a stage where everything is prescriptive. But before we go there, black box AI sounds really cool. You could like imagine some like floating cube doing the Skynet thing. And every time we have some advance where the machine does something that impresses us. It beats Kasparov at chess, or it gets really good at identifying cat pictures, or it starts winning at Go. We get super jazzed about that. Like anytime we get impressed by the machine, we're like, oh, we're done. Like somebody taught a machine how to win at a trivia contest by reading Wikipedia and answering trivia questions, and they immediately decided they'd solved all problems related to reading, and that they were going to start helping top cancer doctors cure cancer by reading the medical literature better than the cancer doctors. It turns out there's like a really significant difference between reading the medical literature and reading Wikipedia. Anybody know what? There's actually two. So the first one is Wikipedia is designed to be read by somebody who doesn't know anything. It's like really good at that. It's like, that's the point. It's an encyclopedia. The second is that in the medical literature, people do a horrendous job of like writing retractions. And part of reading literature is like knowing like when something came out, which journal it was in, who wrote about it. I know that guy's a bozo, all that stuff. And it's like really, it's not just a search problem. It's not just a digestion problem. The funny thing is that certain companies that may have been, some people I worked with in the AI domain were really bitter about the whole Watson thing because they felt like it was really destroying the concept of AI. It seems like we've actually like recovered. It hasn't ended the world. But I do enjoy the fact that even 50, 60 years ago, this is an IBM ad from 1960 or so. Back then, the thing that people were blown away by was doing basic accounting. And they were, again, like, oh, now computers are going to take over the world, this time for sure. So we see this again and again. that people want machines, because machines have figured one thing out, that we assume they can do everything else. And in fact, like most of the major advancements in AI lately have been around doing things like playing children's games. Like getting really good at games that they're bounded. They have very specific rules. You know exactly what it means to win. You can iterate them. You can play them against yourself. You could imagine locking someone in a box and making them learn how to get really good at checkers, and they probably would succeed if they didn't go crazy or kill you. So the machine can sort of figure it out for itself and play over and over and over again. It's fun. If you give my 7-year-old the game of Space Invaders, he can get the hang of it in like 20, 30 minutes, because he sort of knows what they're trying to represent, like what the idea is, what shooting is. He's got a bunch of context. Do you know how many virtual hours it takes Google DeepMind to learn how to play Space Invaders? No, it takes like 1 million hours of simulated play. It takes like a month of setting CPUs on fire. But they don't render the screen while they're doing that. They play faster than real time. But they play like millions of hours of these games in order to get the basic hang of them. And so yeah, we're succeeding at these kind of games, but there really isn't understanding. And in business, most of the decisions you're making, most of the interesting things you look at in Tableau are much more open, much more complex, require a lot more judgment. One way I like to sort of metaphorically tell people about this is I say that AI is like an intern. Like interns are great. You can like make them do stuff you don't want to do. They frequently have time when you don't. But the interns like don't know anything. They don't know your business. You can imagine, I mean, we just launched Explain Data. The metaphor works pretty well. You can imagine having a fairly diligent intern and handing them a problem and being like, could you go check like a bunch of stuff and see what I should look at next? And they'd come back and give you some suggestions, and some of them would be wrong, and some of them would be good. But you wouldn't assume that they were right. Like you wouldn't ask them, what should I do? You just expect them to sort of dig around. It'd be even super convenient if the intern was like free in your machine and took like half a second. So AI can be pretty cool because it goes a lot faster. But it is really interesting as you talk to people who have that, trusting anything to fix with font. I was talking to a really prestigious asset management firm, a many billion-dollar asset, I think $1 trillion asset management firm in the Boston area, talking to one of their major fund managers who's responsible for running a fund with billions of dollars of equity investments and is presumably good at it. Actually, I know he's good at it. He does some pretty cool stuff. But he said, I think that my fund managers are going to be, or I will be replaced by AI, or I should be replaced by AI. And I said to him, why would you think that? Because the AI it's only generalizing based on past experience. It's only going based on stuff it's seen before. It's assuming the system is stationary. It just doesn't have that, And he said, but that's what I do. All I know is what I've seen before. Like, I'm just generalizing based on history. And I was like, it's very humble of you in a way. But it's actually not what he's doing at all. Like, when there's a coal mine, when he's invested in a coal company, and then there's a coal mining strike in Kentucky, and there's also like the governor's elections happening in Kentucky at the same time, and how long is the strike going to go for, and how's this going to get resolved? Like, everybody in this room like knows what a strike is and knows that the governor's election might actually have some impact on this. And if you're like a professional investor, he's only ever seen 2 other coal strikes in his career. It's not like he's generalizing off 2 data points. He's making a whole bunch of judgment calls based on his domain expertise about how companies work, how people work, how elections work. He can phone up a friend and ask them for more advice. He can probably hire an expert on union negotiations. There's all sorts of stuff that he can do. And so it's not the case that people are just riffing off of stuff that they already know or riffing off of that history. And so, the big thing for me is that domain expertise is critically important. In fact, what I've seen in data science is if you can get one person that sort of combines like domain expertise and really deep quantitative skills, like whatever is appropriate to the domain, but that sort of modeling, like if you have that, like you can start a hedge fund on that. And you can start other startups on that. Like that's a fundable startup if you got one person who can sort of pull that stuff together. It's pretty uncommon. And so, what really happens is you need to get a group of people together that have a combination of skills, or you need to retrain people with domain expertise to know some of the quant stuff, or quants and train them up into domain experts. And that's interesting. So what's the domain expertise doing for you? And actually, come to think of it, the quantitative expertise as well. Well, one thing you need to do is know what questions your data can answer. This gets back to Madeline's talk that I mentioned earlier. Your data doesn't tell you that. We had a joke going at Empirical. We called it our product, pre-Tableau, and we did sell the company. We called our product the Empirical Christmas Ruiner. Because we'd come to your organization with this amazing new tool for analyzing data that was going to automatically do every kind of possible analysis, ignoring some power set questions that if you know what that is, don't worry about it. But we're going to do this massive amount of analysis and automatically figure out everything that's going on in your data. And you were like, it's going to be like I'm a kid on Christmas morning. I'm going to come down the stairs and open my presents, and there's going to be all this insight in the presents. And then these lovely people would come to a meeting to look at Empirical and their data and our tooling, and it would be like coming down the stairs on Christmas morning and getting coal in your stocking. We'd be like, oh yeah, no, nothing in your data will tell you why you're losing money on that custody business. Yeah, you were hoping that we were going to replace your traders with AI. I don't think you know what traders do. And this data definitely doesn't know what traders do. So one thing that's really important is having the right data. And if you take any kind of Stats 101 course, any kind of data science learning, one thing that is super critical is a notion of understanding the data generating process. People talk about that a lot. Where did this data come from? How is it collected? What biases were in it? What does it mean? What do the different things mean? Understanding the data generating process is critically important, and frequently something that is sort of missed by people who are purely data scientists, and often missed by organizations that have these sort of data science playground projects where people are just trying to figure something out, and they're hoping they can figure out something that's sort of relevant. Tableau has this sort of lovely core belief. That's one of the reasons that we were happy to join them. I've been happy to join them and happy to be here, is that people who know the data should ask the questions. We want to empower people to ask and answer questions because they know enough to ask and answer the right questions. Not only do they know what the data could tell them, they usually have a sense of what the interventions are, what they might do about it. And that sense of empowerment is really just critical to success. Now, there's this sort of concept that gets thrown around in the analyst community or the industry, this idea of a citizen data scientist. Does anybody know what a citizen data scientist actually means? The way I said that, you're not supposed to raise your hand. Yeah. So actually, if you talk to some professional analysts, they'll admit to you over a beer that it's a really good word. And so in a couple years, I'm sure we'll have figured out exactly what it means. And whatever people are doing, we'll just change it, the word, to mean that thing that people are doing. So as practitioners, you should remember, go figure out what works, and then the analyst will come and describe it back to you. Don't think that they know what you should do. But it is a good idea. And data scientists are sort of found all over the organization. And I frequently like things that analysts tell you what you're doing. So this is an awesome visualization because it's a pie chart and I'm at a Tableau conference, so I'm going to hell. This is an awesome visualization because the data science teams are everywhere. They're all over the organization. They're frequently quite close to different lines of business. And that's cool. The other thing that I like about this visualization is this other block. So the great thing about the other block is if you get on the phone with those people, and that's N is 545 here. So that's 100 odd people in that other block. The people in the other block, if you get on the phone and really probe and what's going on, I gave you a lot of multiple choice options, what happened. The answer is they don't know where they report. They're just not really sure which of these things would apply. That's how common that is. And so when you're looking at enterprise analytics, this is a slide that I'm playing around with, but when you're looking at enterprise analytics landscape, there's a citizen data scientist versus data scientist and whatnot. The most important thing, and because I changed this I stole this and changed it from an earlier version, because one thing to realize is that there are people on the bottom of the slide, the sort of data scientists and the analytic BI developers, they're technical experts. But a citizen data scientist is not just someone who's a bad data scientist or a less skilled data scientist. We just call those people data scientists, and we prefer not to hire them. A citizen data scientist, or whatever we're going to call it later, a citizen data scientist is someone with a lot of domain expertise, who is also familiar with and able and willing to use those sorts of tools. There's a lot of other things that might be true about citizen data scientists, but the key thing is to remember it's really about the domain expertise. And that really matches sort of Tableau. It's how do we help you think more deeply about your data? How do we help, because that's what you're going to need to do to be successful. All right, so you all showed up to a talk that had the alliterative title of Becoming Bayesian, or Making Business More Bayesian. That's cool. So we should talk about becoming Bayesian. The first rule of becoming Bayesian is don't tell anybody it's Bayesian, because that just like freaks them out. Like they took a class in business school. They once had to do like a Bayesian, what do they call it, naive Bayes? They once had to do naive Bayes. I've never done naive Bayes. I'm sure it's a useful teaching tool, but that's not what we're doing here. Becoming Bayesian. So the key thing to realize about Bayesian, and this is a challenge for a lot of business people, a lot of people who come to this black box AI and they've been sold a bill of goods by three-letter organizations, that reality turns out to be unpredictable. There's a lot of stuff that you'd like to be able to predict, but you sort of can't. It's impossible. And yet I talk to people who say things like, I'm gonna take all this credit card data. I'm like in a major bank. This indicates this bank has too much money to fund this guy. I'm in a major bank. I'm going to take all this credit card data. I'm going to determine every bit of consumer behavior. The thing I'm going to start with is I'm going to figure out who's likely to get divorced. I'm like, I have friends who get divorced, and they didn't know they were going to get divorced. Like, what are you going to find? And I can imagine a scenario where they're buying hotels and expensive dinners in this town, but then their wife is in this other town, and so like that's a cool story, but that's like that's happened like once, maybe 5. I don't know. That's happened a few times. That's not how you're going to actually predict things. So reality is unpredictable. You don't have enough data. You could probably never have enough data to actually figure out a lot of what's going on. In fact, because people often want to know what caused something, and it's often quite subtle. So anyway, reality is unpredictable, which is something people are reluctant to embrace. But let's think for a moment what it would mean for business to be more Bayesian. Oh yeah, by the way, this is a neon sign. So I got this big audience, so I can see what happens. This is a neon sign that used to hang in the offices of Autonomy, which was this company that HP acquired out of England. And then they had like an accounting scandal or something, and it was all a train wreck. I want one. So if anybody knows where I can get one, I want an actual vintage one. I know how to get neon made. I want an actual vintage one. All my friends at HP couldn't get me one. So like Bayesian might be like a bunch of math. Like that's a thing you might think is what's going on with Bayesian. When you talk to business people, they get this like Moneyball kick. It's like, yeah, we're gonna like figure a bunch of stuff out. We're gonna win, but we're gonna win like efficiently. We're gonna find the like hidden patterns in the data and sort something out, and it'll be so awesome. Like they'll write a book, and then they'll make the book into a movie about how good a job I did, and like Brad Pitt will play me in the movie. That's how awesome it's gonna be. And like that enthusiasm is great. You should work with that and get them to fund you. But what they often are surprised to find out is that there's like a lot of randomness and uncertainty in actually doing Bayesian decision making. It's like, wait, what do you mean? What are these randomized methods? What are these? Why am I doing this? I'm a little confused. How's this helping me make decisions? So one thing you really have to help people with is embrace the idea that like having error bars is correct. In fact, anybody who is the sort of higher level business decision maker, if you employ data scientists to work for you, or things like that, you should expect error bars on your analyses, or you should expect confidence intervals, a notion of uncertainty, something along those lines. Anytime anybody gives you an exact answer, they're either hiding information from you or doing it wrong. Now, like for example, if someone was going to predict how much your house would sell for, you expect a range. Like they might say, $699,000, but like it means a range. Maybe implicitly you both kind of are in the domain, it means a range, but because they're not actually going to predict the actual price, that wouldn't make a lot of sense because there's a lot of unobserved stuff. And it's tricky because visualizing, and this could be a whole talk track of its own, visualizing uncertainty is wicked hard. There's some lovely people doing research into it. It's awesome stuff. Follow me on Twitter. This is a hurricane plot. Anybody know the most common error people make in reading this plot? Maybe some people in the room have made it. So the most common error here is to assume that the thing that's getting bigger is the size of the hurricane. It's not unreasonable. But I mean, it's the likely paths of the hurricane. And people experiment with different ways of visualizing this and looking at it. So it's tricky to share this with information with people, but when you get down to it and dig into it, well, we'll talk more about things you can do. Predictions and expectations. So I've gotten used to using the phrase, having this sort of talking approach of talking about an expectation rather than a prediction. What's the expected value of this, or what's likely to happen here? What's the outcome? One thing that you end up doing in sort of Bayesian analysis and dealing with uncertainty and working with these things is to think about, are there multiple ways I could get to the same answer? Are there multiple ways I could do the same analysis? They can be as simple. I was like installing foot pads under a dishwasher at my in-laws' place over the weekend. And you need to put the pad on the floor in just the right place for the washing machine to be on top of it. It's like a 4-inch pad and a 1-inch foot, so. But it was like, well, we'll measure from the front and we'll measure from the back. And like it didn't quite work out because the wall was funny shaped and all that, but they were within like an inch of each other. And so it was like, okay, if we can hit the pad like over that, then we're in pretty good shape. We're likely to succeed. So as you're doing this notion of prediction, as you're working through these things, as you're becoming more Bayesian, you should be thinking about, like, what am I really trying to accomplish? How precise do I actually need to be? And is there multiple ways for me to come at that and find out that, well, I have several answers and they differ from one another depending on how I calculate it, but they're all within the same place, so I'm going to get a good outcome. In fact, like one thing that you should really be thinking about, one way you should really be approaching it is to think about what's the expected ROI. What's really going on with that. This turns into, in the pharmaceutical sphere, when they're doing acquisitions, and there's a lot of statistical analysis that goes into analyzing the value of a pharmaceutical that hasn't quite made it to market. One of the ways that they approach that is not to bring all the uncertainty and complexity of the analysis to the boardroom. They actually push the ROI calculation, the utility function, down into the stats group and bring that to the board. And that gives you permission to do more kinds of analysis. And you'll see that in some of the people on the show floor here and some techniques you can do within Tableau. If you can figure out what's the ROI function, what's the loss function, what's the utility function that actually matters to the business, instead of predicting the thing they think you want to predict, you should actually be predicting, like, what's the ROI or what's the number that actually matters. And when you're predicting that, or you're receiving predictions about that, you should be thinking about, first, just like direction. Is this likely to make money? How much money? How confident am I in that? It's amazing how often people just really want. I was talking to a public company that was using machine learning to predict their expected quarterly earnings to 4% confidence interval. And they were like, we've hit it every quarter we've been doing this. Like, how long have you been doing this for? 8 quarters. Do you tell the head of sales what the number is? Yeah. And he always hits the number. Yeah. I don't think you understand the data generating process. So people, just what do you actually need to know? And realize that having a more precise number is not necessarily what you wanted. So being able to put bounds around things, even if they're wider than you wish they were, is more, in my mind, more valuable than having a very precise wrong answer. And a lot of data science techniques, a lot of approaches that people who don't know the domain might take, end up with a very precise wrong answer. Another way to think about this is prediction. While people get very excited about it, prediction is not actually what you want. Intervention is what you want. You want to do something. Don't tell me about customers that are going to leave. Tell me how I could keep them. Tell me about the customers I could keep. Or like I have a young son. He's like 10, but he's going to be a teenager. And I own a sports car. It's a convertible. I'm sure anybody could write me a predictive model that would tell me that my 17-year-old is likely to get into a car accident. But I actually don't know what I should do about it. Like, should I drive a crappier car? Should I buy him a car that's not my car and tell him he's not allowed to drive mine? Should I not let him have a car and his friends drive him around, or does that end up being worse? Like, what's actually going on here? And so just because I can predict something is going to happen doesn't actually tell me what interventions I want. And this is really critical because people are very, very hopeful about using observational data, using data about stuff that's happened in the past to predict the effect of interventions. This was one of our sort of go-to demos at Empirical for trying to help people get to this, was looking at house prices, looking at housing sales, and then doing simulations of counterfactuals. So we could say, like, look at this house with vinyl siding. I can simulate houses that are just like it, but they have brick siding. Well, actually, what I can do is simulate houses that are observationally equivalent given the attributes that I have observed, except for this one where I change it. And what you'd see is that, well, if there was a house that was like this one but different, it would be like $10,000 worth $10 or $20 or $30,000 more. Actually, I think it was like $70,000 more. But the reality is that you don't know that the fact that if this house existed, it would be worth more is not the same as if I put brick on my house, will my house become worth more? Because there's all this stuff that's not in your data that might be driving what you're seeing. Maybe the brick houses are on nicer streets. Maybe the brick houses were built by a cool architect or in a different part, or your neighborhood's really two neighborhoods. Who knows what's going on? And you run into this in business situations all the time. If you want a tool that'll predict sort of who should I have my CEO call on the phone in order to close business at the end of the quarter, and I have a history of data of people that she's called on the phone to close business at the end of the quarter and where it succeeded, that's cool, but you really can't actually do that counterfactual. Because maybe she called the people who she already knew. Maybe she called the people who were in the industry in which she was an expert. Maybe she called the people that the head of sales told her to call and would already be most valuable. And so all you're doing is recovering whatever method that the head of sales was using. So that counterfactual, that approach, you're not really getting to a prediction. What you need to be doing is running the experiment, is understanding what the data can tell you, understanding what your intervention is, and then figuring out sort of how do you get there from here, how do you get more data. How many people here have ever proposed the idea of running a randomized controlled experiment? Like hands? Okay, cool. That's like 20%, something like that? Cool. How many people have actually gotten funded to do it, have been allowed to do it? I really want to see these hands because I want to count them all. 7, 8, 9, 10, 11, 12. Like half, wow. You guys are way better than data scientists. I usually, if I ask that to a room full of data scientists, the first question, 90, 95% of the hands go up, 100% of the hands go up. Second question, 2. It's critically important, and yet people often don't do it. So I have a whole talk track about that I actually clipped out of this, but given this audience, maybe next year I'll do that. What can you do with this observational data? What am I going to do given that I know what happened? I'm not running an experiment right now or haven't yet. What can I do with it? Well, if you have domain expertise, then it can be actually very helpful to explain things to people, to explain what's going on, to explain why things are happening or what they're seeing. Explainable AI sort of becomes part of that. And there's a number of ways in which explainable AI can get used. It can be sort of reporting oriented, where I build a model and then I drop out a 45-page report that nobody ever reads. Or maybe somebody does read it. That's probably presumptuous of me. I drop out a big report, or even a little report. That could be cool too. Or it could be interactive, which is my bias, in case you couldn't tell, where you can ask it multiple questions or explore different predictions and see what's going on. An important thing to think about is, are you trying to do something that's about approving decisions where the human is supposed to know better? Or are you doing something about justifying decisions, either to a regulator or to that same human? And this is an interesting split. So if you're doing approving, then you want to make sure that the human has a lot of information, and there's a good chance that the machine doesn't know the right information to look at. Because the machine's already wrong in the cases you care about. So the approving case is actually really tricky. And usually best handled at the model scope rather than the individual prediction scope. But for justifying, you can do it at the individual prediction. And there's 2 situations where you can be doing justification. So sometimes you're trying to explain to regulators why you made a decision. But the one that I find fascinating is where you're using explainable AI in a justifying scenario in order to drive compliance, in order to drive people following your recommendations. I was talking to a customer that was working on anti-money laundering. They had a system for automatically detecting when people were laundering money or when bad transactions were bad. And they wanted an explainable AI for that. And this is when I first understood this split, because I was like, oh, you want to figure out if the model's good. And I went at that repeatedly, and it was like, no, we trust the model, completely. The model's probably better than the people. It's like, okay, then why are we doing this? Well, because the people have to get on the phone with the other bank and argue with them about it and explain why we canceled the transaction and why we don't whatever. And they're uncomfortable doing that if they don't have a good explanation. So we want to make the people feel more comfortable following the recommendations of the machine. And that's why we need to explain it to them. I was like, oh, okay, yeah, so that's a thing you could be doing. So conveniently, explainable AI is kind of this big, hot area where there's different approaches. This is DARPA's concept of explainable AI. This was the funding that led to Empirical, so I feel like I owe them a shout out. Because you have this situation where you have a task that the user is doing, and they want to get a decision or a recommendation of some sort. And the ideal scenario is that there's some sort of explainable model And there's also an explanation interface, and they can sort of go back and forth and understand why things are happening and what's going on, and that's pretty lovely. One thing I've seen a lot more of, and this is a situation where you tweak the model and you deliver the interface. Something I've seen a lot more of are using models to explain decisions that were made by something you're not necessarily really able to understand. So you might have a black box model, or that's figuring out that something is a cat, and then you want to be able to sort of extract those features out and figure out what are the attributes of this that might make it a cat. Here's some features I understand. Here's some features I don't fully understand, but maybe I can get a domain expert to understand them. Like all of these pictures have this sort of funny thing at the bottom that we could call cat ears. So you can deliver that either in a situation where you sort of control the model, or in situations where you're dealing with black box models. So what we brought into Tableau with the empirical analytics engine, the explainable AI sort of approach that we were taking, was being able to automatically model the data and then deliver interactive querying for sort of flexible exploration. One thing they sometimes tell you is that, I think it's Peter Thiel, I owe this quote to, is that the best startups are based on a secret. Some sort of secret. And the best secrets are ones that even when you tell people, they don't believe you. Like the secret for Airbnb was like, people will pay to sleep on somebody else's couch, especially if it seems cool. And a lot of investors were like, that's a stupid idea. In fact, there's a great post by somebody talking about the value of finding stupid ideas with traction. But anyway, the best startups are based on a secret. The secret in empirical was it doesn't really matter what model you choose. Was that there isn't really, I put this up like it's a quote, but it's basically my words. There isn't really a trade-off, as much of a trade-off as people think, between complexity and explainability and accuracy. Why might that be? Because there's all these companies out there on the show floor that are going to sell you tools that dial the complexity and the accuracy up to 11. All right, well, I'm a little bit, so first of all, I told lots of people this, they mostly didn't believe me. Welcome. What's really going on is that most of the data you're working with is crap or limited. You can't get within 1% with your data, no matter how hard you try. And so all those spiffy algorithms are just giving you different places of landing within that 1% envelope, if you're lucky. In fact, many of them, because they end up so sort of over-focused on the training data set, they may actually have worse out-of-sample performance as a result of their complexity. And as a result of their non-explainability, your domain experts are never going to be able to tell you what they think about the out-of-sample performance. And so realizing that, and there are places where this is not true. Like, you should be so lucky as to find a part of your business where all you need to do is build a predictive model and keep making it more and more precise. And then just money happens. Like, that is amazing. Like, this whole company is based on that. But the vast majority of decision making, and almost all of the high-value decisions, are not like that. They're non-repeatable. They suffer from limited data. The data's messy. There's a lot of debate about what question we should be answering, what question we should be asking. And so, one thing you realize as you're taking these sort of Bayesian approaches, as you're embracing the notion of uncertainty, as you're understanding that you should be thinking about what's the actual benefit that you're going to come to, is to realize that throughout all this modeling, simplicity, explainability is tremendously valuable, and all that complexity and accuracy may not be. So I like talking, but I also feel like I'm required to do a demo while I'm here, so I felt like showing people a cool thing. How many people have heard of Lime or Shap? They're not the same, but they're wicked close. Yeah, okay, cool. So I just want to show you what it looks like to do. This isn't Explain Data. I assume everybody's seen like an Explain Data demo. You should totally check out Explain Data, it's awesome. This is something this is just a workbook, so there's nothing you couldn't do here, but it is separate from Tableau. Did that do it? Oh, hey, it worked. Perfect. Oh, no, it didn't. My slide just looks a lot like my other screen. What do I have to do? I told the guy at the back of the room this was going to do that. And you can see this is a pretty ugly dashboard because I'm not very good at Tableau dashboards. I think I'm supposed to do, no, wait. That didn't work. You all know better than I do. We won't do that. So what do I have here? I have a really ugly dashboard because I'm bad at Tableau. What do I have here? And I totally skipped the thing where you're supposed to make your dashboard pretty for TC, and they have consultants for that, and I didn't. because I wasn't sure I'd have time for this. So this is a data set of military families and like information about their spouses and their financial situation. And we've trained a really simple predictive model on this with some tactic, I don't know, boosted random tree or something. We've trained a model to predict whether or not people are likely to have more or less than $50,000 in household income. It's a pretty straightforward thing. Like you could train a better model about like loan default or something, but this is cool. And it's a public data set because there was like some military thing where people were being taken advantage of in loans or something, and so they published a bunch of cool data. Anyway, so what I have going on here is that I did a pre-processing step. So this is, there's that cheat. But what I've done is, so like here's an example of someone who's, they're 45 years old. They're married to a civilian spouse. They have a PhD, or their spouse, I think, has a PhD, works 50 hours per week. And they had, on their most recent taxes, they had, $75,100 of capital gains. So if I mouse over here, thanks to Viz and Tooltip, which is awesome, what I have, oh, right, I'm supposed to do that Zoom thing that I don't know how to do. Shoot, well, never mind. You'll all have to suffer. I'm sorry, because I don't know how to Zoom on this laptop. So what you're seeing here is a set of explanations for this particular prediction, that the reason we think this family has greater than $50,000 income is because they have capital gains, they're married to someone who works a lot of hours and has a lot of education. And the interesting thing when you're working with something like this is Lime, like these techniques, is you get different explanations for different predictions. So as you cycle through it, it's like, okay, this one, they don't have the capital gains, or this one actually does have capital gains, but here's one without, there's no capital gains, so you would think capital gains sort of pushes you in the other direction. It's a pretty strong signal. But then the fact that they're married to a civilian spouse who's in an exec managerial position pushes you in the other direction. So we're still very confident. And there's plenty of things in the middle that get sort of messier, more ambiguous. You can come all the way down to things that are where you're very low likelihood, and get the capital gains. This person's never been married, does not have a high school education, works less than 40 hours per week, is 60 years old. Like that's just not looking good for greater than $50,000 of household income. And so that's sort of Lime, which is one technique, one approach, where what you're doing there, what I'm doing there, is taking that concept of explainable AI, taking that concept of explanations, that concept of modeling, and bringing it into the Tableau environment, bringing it into a familiar visual environment where I can expose it to domain experts, and they can go through and like check it and be like, does this make sense? What would I do about this? What information is there in this? Because if you can't run the experiment, if you're not allowed to run the experiment, if it's impossible, what you really have is your ability to reason about the domain, to think about what's going on, to come up with ideas and explanations and interventions, and think it all through. And that works best if you have lots of data available. That works best if you have flexibility to explore that data. It works well if all the machine learning, any of these data science techniques that you're bringing to bear, they can be exposing as much information as possible so that people who really know what's going on can do something about it. So what's the intervention? Huh? What? Sorry. So at the beginning, we mentioned that there's organizations that make data-informed decisions do better. So we have this observational data that if we just look at the world, we haven't run an experiment. As far as I know, I can't convince anybody to randomize whether they adopt a data culture or not. That'd be cool, but I think if I had that ability, I'd just make them all adopt a data culture. I might be biased. So organizations that make data-informed decisions do better. But the interesting question is like, well, what can we conclude from that? There's like correlation, causation we need to pull apart, like what's really going on here and whatnot. Well, unfortunately, we just don't have the data. I mean, we've looked at a lot of different things. We've looked at many different things. And so what you need to do is sort of lean into domain expertise. And I have the microphone and you don't. So I guess I get to be a domain expert. So I'll share my sort of opinion about what I see as the intervention. And I'll share it in a metaphorical way. So we're talking about becoming more Bayesian, which is really just becoming a data-driven, thoughtful organization. So AI is like running a marathon. I thought it was like an intern. Anyway, it's also like running a marathon. I have a friend who's an AI researcher who thinks metaphors are like the origins of intelligence. I think he's a little nuts, but that's fine. Metaphors are cool. So AI is like running a marathon. So running a marathon is terrible for you. Oh, okay, well maybe it's not quite like, but anyway. Running a marathon is terrible for you. You should not run a marathon. It's like bad for your body. But training for a marathon is actually really good for you. So the best thing you could actually do is train to the point where you're able to run a marathon and then don't run the marathon. Or like run a half marathon or something. I don't know what you do. I don't actually run. I'm fat. But no offense. but the idea here is that it's good that all the preparation that goes into it, all the process of developing the habits, developing the behaviors that go into it, that's where the benefits come from. The actual doing it is not where the benefits come from. You don't become healthy by running a marathon. I actually have a friend who on a bet ran the Boston Marathon on no preparation and I think approximately no sleep. He's a very special person that was also not good for him. I do not recommend adopting AI without any preparation. So the way I like to think about this is that adding AI to your enterprise is not the intervention that makes you a better company. It's all the preparation that it takes to do a good job at it that makes you better, that allows you to make better decisions. It's the data, bringing the data together, bringing the domain experts together, having data science projects with like actual goals, articulating what the interventions are, what you could possibly be doing. All that prep work, all that developing the organizational capacity to be deploying these kinds of decision support technologies, that's tremendously beneficial. The actual step where you do the AI bit is, I mean, it's often has some benefit, but it's not what makes the big difference. It's all the preparation work that makes the big difference. So most data science projects are failing. Involving domain experts is really how you can help people ask the right questions. And my completely unbiased opinion is that using powerful interactive analytics tools like Tableau is the best way to get domain experts engaged with your data and engaged with the kind of decisions and problems and realities that you have as you're doing those data science projects. So thank you very much. That's it for right now. So is there anybody kicking around microphones? Do we do questions? How do we do questions at these things? This is the first talk I've attended. I apologize. Anyway, I think we're good. Anybody has questions, you're welcome to come up to me afterwards. Oh, I lost my mic. There we go. Fill out my survey, and feel free to email me, follow up on Twitter, all that lovely stuff, and let me go find those other talks. So if you hurry, then you can get to How to Lie with Statistics.